Okay, so this is 7-4, what it deals with, our learning target for 7-4 about key steps of muscle contraction. But I'm going to be giving you guys different steps, worded differently, more of the terminology that we used in class and talking about the things that we talked about in the notes. There's no mention of sodium ions here, for example. They do talk about the calcium ions, but they don't go into detail about calcium ions binding to certain parts of actin molecules within the or on the myofilaments. So, but this is a good idea for the big picture. It helps. Keys to success. Yes, Chance. Thank you. All right. So the first step is acetylcholine, which we know that's really just referred to as ACH, is released into the neuromuscular junction. We did talk about that, where the neuron meets the muscle. We did mention axonal terminal, although in the notes I referred to that as synaptic terminal. Same thing though. All right, so this ACH gets released. Step 2 is going to be number 4. All right, it diffuses across the neuromuscular junction, which I actually called that in the notes, the synaptic cleft. This little gap between the neuron and the muscle, and binds to receptors on the sarcolemma. This is really talking about the muscle, or what I call the motor end plate of the muscle. All right. The more I write, the less convinced I am that mine is easier. All right. The third step. So this doesn't mention anything about that causing sodium ions to come into the muscle. And when the sodiums come in, they cause depolarization. So when we talk about poles, we immediately go back to thinking about what we learned in elementary school about magnetic poles, North Pole, South Pole, one of the first things we learned. But realistically in science, electrical poles are much more prevalent than magnetic poles. That might be untrue. But anytime you have a buildup of positive and negative charge is considered to be a pole. When you have opposite charges, we're talking about polar. All right? It is shocking. Um, so far. So what happens is when the sodium ions go across, we no longer have this buildup of positive charge and negative charge, so they call that depolarization, which causes the action potential to go through the muscle. Now, the next thing that's going to happen is we are going to have the action potential carried deep into the cell, causes the release of calcium ions is really the important part there. All right. And then the calcium ions are going to, that's where the calcium ions are going to bind to the actin molecules by joining onto these things called troponin. It's going to make this other molecule clear the active sites so that myosin can attach to it and grab on, form these things called cross bridges. All right. All it says here is that the cell shortens. Okay. So the cell shortens, which we know is muscle contraction. Okay, so that's here, contraction. And now I believe the last two steps are just talking about calcium being actively reabsorbed and allowing the muscle to then go back to its regular relaxation phase. All right. Okay, so that is number 8. Everybody good with that? Everybody paying attention? I gave you guys number 11. 12, what happens when we're in oxygen deficit? What do we do? Breathing hard. What do you mean by that? Deeply. Breathing deeply. What about the rate? Okay, so increased breathing rate and deeper breaths. about it, but I didn't necessarily give you all the answers. I got it, Chance. Thanks, though. So I'll just. It's just in this example with this particular muscle that's shown which one is considered. Well, right. And I can tell because they do two drawings of it. They do a drawing of it there, and then they do a drawing dotted like that. So that's movable. It's moving here, right? Okay. And so the emu this here. See, so here it's only this distance. At the beginning it was this distance. Right? This is contracted muscle. All right. Spot on the immovable bone where it's attached, we call that the origin. And where it goes on the movable bone is called the insertion. And we also have a couple other things called here, tendon. Where muscle attaches to the bone. All right. So that is all of that for 14. Good. So number 17, I gave you that. And then 18. So I am going to have you guys be able to do a couple of the functions. Some of these are important, I think. Like which one is used in smiling? Oh, that's a good saying. Okay. All right. Now, on this, so the ones I check are ones that you should know their functions as well. So we should also know A, buccinator, used to suck in your cheeks. We should know winking is orbicularis oculi. We should know the horizontal frown crease of the forehead is going to be the frontalis. And the last one is the kissing muscle, which would be orbicularis oris. Okay, so just the first five. All right. Although, as I looked at this, I mean, 6 and 7 are cool, but I didn't tell first or second hour to know them, so I'm not going to say it. But prime mover of jaw closure for chewing is going to be masseter. I'll show you on the next diagram. Are you guys good with this if I erase? Okay, so labeling these. The frontalis, that's the frontal region. Yep. And this is the temporal region on the side of the head. That's the temporalis. So it talked about the masseter being the prime mover for jaw closure for chewing. Okay, this is the masseter. And then the temporalis is being a synergist, meaning it works with the masseter in chewing. And that's why when you chew, you see the sides of your head will go kind of move. All right. All right, and then we have some round muscles. So any round muscles are referred to like orbs around, orbicularis. So we have this one is orbicularis, that's round. Where else do we see a round muscle? Here. Okay. So that's orbicularis as well. So then we have to specify by region. The eye is referred to as ocular. Okay, so this is orbicularis oculi. And the mouth is considered to be the oral region having to do with mouth. So orbicularis oris. There. All right. We have the buccinator. Zygomaticus. We can see how that could make somebody smile there if it shortens. And one other one that we have on here from a side view is sternocleidomastoid. And it's telling all the things that it's attached to really. The sternum, the clavicle, and what's called the mastoid process back here on the skull. All right, sternocleidomastoid. I think I got them all. Is everybody good with those? All right, on this one, so we're looking at the torso posterior, or sorry, anterior view. Okay, so there's our answers to this part. As far as functions go, straight muscle of the abdomen. You can know that is rectus abdominis. All right. And the other one I wanted you to know is the one, it says inspiration here. Uh, that's not inspiration like listening to Chance's words every day when he comes in. That means like breathing. All right, so breathing, diaphragm, unpaired muscle, acts with the muscles above. But mainly, I just wanted you to know it's the main muscle involved with allowing us to take breaths. Okay? Diaphragm. And so now we have to label it. You guys good with those answers? Yep, shooting a basketball in psychology. All right, so here's a front view of the sternocleidomastoid. All right. So we also have in the shoulders, we have the deltoid muscle. We have in the chest, pectoralis major. We have the rectus abdominis in the middle. We have the external obliques to the side. And that's it. So you should be able to label those. Okay? Pretty easy. Cool. Nervous system. Okay, so last part. Yep. Number 20. And so functions here, just the first one. Muscle that allows you to shrug your shoulders or extend your head. Trapezius muscle. Think you guys can get that? True, true, true. All right. So labeling. Torso. Sorry, dorsal view of the torso. It's torsal. We see the deltoid again. And here's the trapezius. Yeah, it is big muscle. Yeah, another big one here is the lats. So we have the traps up there on the back, and then we have the lats. Trapezius and latissimus dorsi. We also have down here in the lower back region, the lumbar region, we have the quadratus, lumborum. I think that's all for this, right? And bleep, bleep, bleep. That's all, folks.